All right, so let's carry on. So, more ways to sneak script code into the user. So if you cannot insert script, then you can try things like this. There are a lot of sneaky ways. Like here, you put it inside an object data tag. Here you put it inside an object data tag in base64 encoding. So it will be interpreted as script on the server, but the actual thing you send up doesn't have it, and so on. There's a lot of sneaky ways, so I got an example of that here. So this thing, if you send script alert 1 script, it blocks it. You're an evil hacker, you don't get the message. But there are various ones here that work. Here's the one with object data, where I am still sending the script tag, but it's inside an object tag, and therefore perhaps will not be filtered. And nope, it caught that one. So that didn't work. Here's where you use the base64 version of it in the object tag. And that one worked. It unbase64'd it and ran it, and apparently the filter was before that, unbase64ing it, base64 decoding it. And here's one where it doesn't run right away, but it runs when you click it. And like I mentioned, different browsers have defenses, and these two will not run in Chrome. But this one will run in Chrome. It's not running yet, but when you click this, it would run. Not now. Oh, that's interesting. Now it's blocked. Now I might be able to tell why if I look at the developer JavaScript console. It might tell me why. Yep, not allowed to navigate top frame to data URL. Neat. So here's the defense. I'm not exactly sure what this means, but the browsers keep adding more cross-site scripting defenses. Because as you've seen, it's really a problem in your browser. Like especially document object-based model. If I'm taking data from here and putting it on the page, then the server has no chance to clean it. So my browser would have to notice that. And browsers are getting more and more picky, and including some defenses. So, all right. And then there's event handlers like we've done before. On error, we'll run it. On state change, activate, you can do on-page load. There's a bunch of ways to run things. These event handlers, a way to inject JavaScript. There in HTML5, you've got autofocus on blur, on scroll, on mouse move, on error. Many, many event handlers that will all run JavaScript if you can inject them. You can use script pseudo protocols like JavaScript : like I said, so it looks like any place a URL goes. If you're in Internet Explorer on an old version of Windows, you might be able to use Visual Basic Script, the VBS protocol. HTML5 gives you some more ways to inject JavaScript. You used to be able to put it in a style. In later versions, you can put it in a style. I don't know if you can do this in Edge, but you could do it in Internet Explorer. You could put script, an event handler, in a style, which is kind of crazy. So if you want to obfuscate this on-error attack, you can try capitalization, or you can insert null bytes. And the purpose of a null byte is it'll be ignored by a web server typically, but it's probably not ignored by Web Application Firewall, which will interpret it as terminating a string. At least that's the idea. All right. And so you can put in invalid tags, like there's an invalid tag X. That's not a valid HTML tag, but this is a fundamental problem with HTML. HTML has many versions, and people add scripts with other things. So if your browser comes across a tag it doesn't recognize, it just does nothing. It lets it through. It does not prompt an error or anything because it says, well, that must be a tag that's added in some later version of HTML that I don't know about. So you can add empty tags here, and then it'll run in the browser. And now, even though this is an invalid tag, you'll be able to click here and it'll run the event handler, even though the thing's not there. Well, I haven't opened Zoom yet. I won't open it until after the lecture, honey. Anyway, all right, so you can change your base tag to point to a URL, and then scripts will load from that location instead of the official location. So people that load scripts with just a relative reference like this are vulnerable to this. You can change the base, and now when they try to load their script, they're actually loading a script with that name from your server. So that's a cute one. You can put a space after the tag. If it's blocking the word script followed by a space or something, then you can avoid putting in spaces by putting in punctuation marks, which will count as a delimiter, like a comment of any junk. You can often put in other things. All right. You can put a null byte all over the place. You can put backtick in instead of apostrophe or quote in IE. That's what someone was saying. The guy wanted to filter less than, greater than, and they said, well, filter quote marks. Yeah, but sometimes you can use strange characters that are not supposed to be quote marks, but some browsers will let you do it. So, and this is the sort of thing. If the filter is unaware that backticks work, then it treats this as a single attribute. This, what's that?
That's a forward tick.
It is. This should be a backtick. I think the picture is wrong. I think you're right. Anyway, yeah, all right. I think you're right. That image is not correct. Anyway, so attribute values, you can insert null or HTML encode characters, other ways to change this alert. So here's the alert with the null in the middle of it. Here's the alert with the L turned into this HTML encoded character, both of which might fool a filter. And here's more HTML encoding in various ways. And then some applications perform URL decoding twice. In particular, old versions of IIS did this. So you could use %253, the %25, %253cc, 253c. %25 would decode to %, and %3c would decode to a less than sign. So that strange combination would be interpreted as a less than sign. And sometimes you can use double angle quotation marks to indicate things, because some app frameworks will interpret those as less than and greater than signs, which is, again, kind of crazy. All right, and sometimes you can put in extra brackets. Here's Firefox will accept this weird thing, despite it not having a valid script tag. This is just the kind of madness that you have to get used to. There's a web developer add-on that will help you see the generated HTML after Firefox has tried to fix the code. So that would be another way to help find these kind of weird problems where weird code is changed. You can try different character sets. UTF-7 lets you use this plus ADW script for tags. Plus ADW is interpreted as something. US ASCII, we've seen before. And UTF-16 is the Microsoft Unicode with null bytes after each character. These are all ways to strangely encode the original character set. You can set the character set in the content type header or a meta tag or a charset parameter.
This all depends on the server. Can we interpret it? All those encrypted?
Yes, it all depends on the server interpreting it. Yeah. And this one is really crazy. There was a coding scheme developed for Japanese characters. So you would use, it would use 2 bytes. So if you had 2 pieces of input used in the response, if I can input here and I can input there, input 1 blocks quotes, but what I can do is inject this %F0, and that will start this shift GIS, and it will eat up the next byte after it. So this will eat the quote, interpreting it as part of some Japanese character, and now I'm in a string. And now I can just complete the string here. So this is kind of madness. You can inject something that will suck up and eat one character that the developer put there, which is pretty awesome. All right. And so if you want to sneak in script code, you can do Unicode encoding. Here's the Unicode encoding for an L, \U0006C. You can use eval to evaluate things. You can use extra escape characters to just change it so it won't match the filter. You can use A to B. A to B is a JavaScript code to do base64 encoding and decoding. So you can use A to B of this, and that will decode into your script and so on. You can dynamically construct a string. So you can take eval and then AL plus ERT plus 1. You can do string from character code, put in numbers to build it. You can do A to B to reverse it from base64. All ways to sneak in the word alert without having it literally there for the filter to block it. So your filter has to be able to do all this decoding before filtering. You can avoid using eval. Ways to sneak eval in. Here you sneak in function : I think that might work. Here you're just not quite sure what's going on here. Then there's alternatives to dots. If you can't do document.cookie, you can sometimes use square brackets or put it in separate parentheses. Give you a dot is not allowed to sneak in that character. All right. And so I had a demo of the eval. I think I'm not going to bother with it. You can combine multiple techniques. So you use Unicode escaping for one character and URL, or this looks like HTML encoding for the other. So you mix two things together. And VB script is in your book, but it's not important anymore because I think VB script is pretty much gone. So you can encode certain characters. These are just various tricks. Try encoding characters. Sneak in script using various layers of encoding, non-standard syntax, null bytes, and all that jazz. If it doesn't remove all instances, you can put in a recursive script, a script inside a script, and that might get through. All right. You can inject into an event handler with like on click, and now you don't have to put in script tags. They're already there. You can beat length limits by making short attacks. There's a whole industry of making JavaScript very short. There are online forums to pack your JavaScript to make it as small as possible. If you have multiple injection points, then you can inject things like a quote that'll match the other quote to just wipe out whole blocks of code. Yep, here's 3 fields. So you can inject in a way where a part of it goes here, part of it goes here, and part of it goes here, and it adds up to your attack. That sort of thing to overcome a length limit. And you see what happened here. Script alert / script, and it injected like the beginning of a comment and the end of a comment to kill off everything in the middle. So this is a way to turn the code into what you want it to be. And you can convert reflected to document object model if you, this is a script that will eval location hash slice. So you've injected this script, and the script will read from the URL. The hash is the part after the pound in the URL. So you can use reflected cross-site scripting, which puts in code that from the document object model, and that will defeat a length limit. You can put in this short thing and then put a long thing up in the URL. So, all right. Anyway, that's a bit of general information. All right, so 12D is here. All right. There's just a lot of tricks. And you practice a lot of them if you do the Web Security Academy stuff. Everybody. All right, so what attack inserts the first part of a 16-bit character to remove a character? That's that Shift JIS thing. Sounds great. I've never used it, but it sounds pretty powerful. All right, what character may cause a filter to stop working? Yep, the null byte will terminate C strings. And what function decodes script written in base 64? A to B. Base 64 is always ASCII, and when you decode it, you get the original, which could be binary. So this is ASCII to binary, binary to ASCII. This is base 64 encode. This is base 64 decode. All right. So, all right. Alexander has won twice. And Austin has won 3 times. And Kat has won 3 times. All right. So I got the winners. Stop the video.